Hello and welcome back. Today on the bench once again is the Tech Type 547 valve oscilloscope, and as you can see the power light there is glowing nicely and will hopefully last a long time. I'm going to turn that off because although I've made some progress, we're still not out of the woods yet. There's something very wrong somewhere. I've gone through a hell of a lot of the transistors. One of the ones that I replaced, that one I think, is dead. Because that, can you remember, like in the last episode, I said that I wasn't sure that it was in the right place because the collector had gone through the legs, as it were. Well, it was in there wrong, and as a result it died. I'm just looking for it. Also another where are we, Q464, that died. That was another one of those 2N2501s. The leg fell off. It's in the scope somewhere, it dropped off. This is going to be an expensive do. I'm going to see if I can find a better replacement than a straight 2N2501, because I'm sure like a BC546 or something like that would actually work probably. What else have we got? Yeah, I've had a few of those 2501s come up with, they're okay, but with 0 HFE. I've had quite a few come up like that, but then like a similar one, like, so we've got Q75 and Q65. One tested 27 HFE, the other one 0 FE. I don't know what that is about. And you see this one here, an HFE of 96, current gain of 96, so I don't know. So at the moment I've just had immense fun trying to put the one that died, Q6564, a 2N2207, replaced it with a 2N4890. Hold on, I've got one somewhere. So this is the transistor in question that's died. It's got a, what has it got? It's either got a base emitter short or a base collector short. Yeah, base emitter short. This is the replacement, so as you can see the leads are different. However, just borrow this a minute, this isn't one of the bases. On the bases on the Tektronix, it's like a dual type, so you've got like a hole here like in line, and then this one. So let's go and have a look at the one I got on there and show you how I did it. Yeah, this really isn't easy to film. It wasn't easy to put in. So what I've got one of my sticks, fettle, you know, one of my whittled sticks, bit of blue tack on the end. What will we do with that blue tack? A light, and I've stuck that in, and it's got a heatsink on it. The heatsink has got a split in it. I've aligned the split with the emitter, and then what I'm going to do, I'm going to flip the scope up on its, you know, how it's supposed to sit, and then check that that is correct, because I don't think it is correct. But before I turn the thing on, I want to make sure it is. So let's go and do that, and then we'll have another look. So that's the transistor underneath there, 564. There's 47k here, goes to the base, and also it goes to this little adjustment pot here. So, is that right? Right, I think that's right. The emitter goes to this 47k and this pot. So that's the emitter there. That would make sense because the crack, when we look at it there, is facing that way. this lead here goes to here, which is the base 100k, and this diode. Sorry, I'm trying to frame this. And the collector goes here. You see, like, I don't know. We could try to get the tester on it. I don't know if it's a testing circuit. We can try. We'll try that. That's telling me that shite. Don't know why it's saying the battery's empty, because it's got a power supply on it. Right, that's telling me that the base is 3. That's right. The emitter is 2. This one. And this is the collector, which is wrong. I don't understand that. I do not understand that. It's a right pain in the arse, this is. It really is a pain in the arse. That shouldn't be that. So that was saying where I thought it was the emitter is the collector. Oh, for fuck's sake. Right, I'm going to have to look at this again, because right, let's have a look at job. This is correct, isn't it? It doesn't matter what, they're all the same fucking package. Pardon my French. It's getting towards the end of the day. My back's hurting. I'm getting a little bit tired and pissed off. Right, this is a TO7 package. TO7, TO5, TO fucking don't matter. They're all the same. You've got like this nubbin, whatever you call it here. That's a emitter. E, B, C. Collector is that. With this style of package, it goes E, B, C. Right? So, our base, transistor base on the scope, goes like that, like that, like that, like that. Those are joined on the base on the scope. You can see that. Okie doke. That's the base. Here's a emitter. Here's a collector. I don't see. You see? That's got to be right. But the tester's saying it ain't. Well, this is sometime later. It's been a few days since I've had a look at that. Been doing other things. So I think I was on the lines of, have we got EHT where we should have it? I.e. we should have minus 1950 volts on the somewhere near the around the sort of intensity pot, and minus 1850 volts on the cathode. I couldn't really find that out because my HT high voltage probe didn't seem to be recording, you know, it was just giving me anomalous readings, so I had a cloning plan. Mike the bike has kindly lent me his 547 manual, which makes life loads easier. So my cunning plan is, instead of measuring the voltage like here with regards to earth, measure the voltage across each of these high value resistors and then add them all up, because my Fluke 25 can measure up to 1000 volts and a bit over. So what I did, I sat down, added up all of the values of the pots, and then divide and got that number, and then got the number that I needed, like, you know, saying 1950 volts. So here we basically got two 7.5 meg resistors and a 1 meg pot, which is the intensity control. So by doing that, I got a rough value of what we should get. So we should get 914 volts dropped across each one of those 7M5 resistors, and the pot 122 volts. And then I did the same for the cathode potential divider circuit, all these here. and got some more there. So I've written, you know, thing here, blah blah blah, write it down as we go along and see how we go. And then since I sort of had this idea, I joined Tektronix, which is a like a group. It's not a, I don't think it's a forum as such. Anyway, essentially, you know, it is. You write in and ask questions, and so one of the last replies on there was, if this circuit is running away and not regulating, then that could have the symptoms that we've got, i.e. not much vertical adjustment and not much horizontal adjustment. I don't know why that is, but we'll watch it anyway. We'll have a look anyway. And apropos of that, see these doings here. Well, this isn't me. This somebody, whoever had this manual, either Mike or the person before him, has drawn that. And so I looked at that. On the TechWiki 140 pages, there is a document where it shows you all the subsequent like changes that Tech did to the 547 over the years to cure like various faults. This here is a 24 volt Zener, 400 volt rectifier diode, 100k resistor, and that stops the screen grid of this 6AU5 exceeding, I think it's 125 volts, and if it does, it clamps it. So that stops that runaway thing. So that's something I might, you know, do. I've got 24 volt Zeners, no problem. And then so while we're at it, we'll also take the reading here. I've actually got my head around it and worked out what that means in RMS. We should have 220 volts RMS AC, obviously, on that anode of that V800 6AU5. Right, let's go and do it. Well, I took those voltages off camera because it's best to, you know, do high voltage stuff when you haven't got a camera in the way. These are the results. Across the top one there, let me show you the picture so we know what we're talking about. Being very careful with this manual, it's not mine and it's old and there's not many of them about, I dare say. Right, so across these ones up here, these are what we got, and it should be 1950, and we got 1606 volts in total. Don't know why that is, not sure. There's a few things don't make sense. And then as I was taking the voltages across this potential divider here, I thought these bloody readings are at, I wasn't even looking at, you know, what I've written down here, but I thought the readings were high. And according to this, it is 400 volts over on the cathode, which might explain things. One thing that really didn't make sense, across that 500k high voltage adjust pot, we should get 100 volts, and we're only getting 8.8 volts. So I need to check that again. So there's a few things don't make sense there. On the V800, which is our regulating valve over here, I said we should have, what was it, 220 volts RMS or 310 volts peak to peak, is it? Yeah, 210 volts peak to peak, 220 volts RMS ish, and we only got 130. So you would expect, if that's over, for that to be too high. So what I'm going to look at next, I'm going to scope out the anode on V800, adjust the high voltage pot, and make sure that it is adjusting, you know, the waveform is going up and down. I'm sure I've already done this, but I'm just going to go over it again anyway. And what else was it to check? Right, I don't know. Yeah, I'm going to check the voltage on the screen grid as well. Yeah, blah blah blah. So a few things to do, and I shall check that all off camera as well, because I mean you must have seen this back in a minute. So sometime later, and where do we go from here? We've got a theory that there is too much EHT, too much high voltage going on the cathode ray tube, and I think the idea is that because the potential between anode and cathode is too high, that the beam is going really quick, accelerating too quick, and the various plates haven't enough time to move that beam. That's the idea. So how do we try to rectify it? Because I've tested this and it is regulating, but still no change. So let's go and have a look at the schematic. So we've got two circuits essentially that we've got to look at. Well, the only way this thing can regulate, the only way that we can lower the voltage that the cathode ray tube sees is to lower the voltage over here, the whatever is it, 500 kilohertz sine wave going into the HT transformer, trying to reduce that. To do that, we have to try and reduce this voltage going onto the screen grid. So one thing we could try before we do anything else is to disconnect that from pin 8 from the screen grid, and then feed in a voltage from somewhere, say via a pot or something like that, and see if that improves the situation. And then the only other thing I can really think of is to implement this mod, although I'm not quite sure that will solve our problem. And then the other thing I thought of was to look at every resistor, check them for value, and see if that, you know, see if we find something that's not right. I doubt that that'll be the issue though, to be honest, but it's somewhere to look. That's, you know. The other thing could be, of course, is that we've used silicon rectifier, so there's not as much voltage drop across. I'm not quite sure what the voltage drop is across a 5642 rectifier diode, but I would think there is some. It's going to be more than the 1.4 odd volts that's the forward bias voltage of a silicon diode. So yeah, I'm going to crack on with that and then see how we go. So what I just said, discount that. So we've got the builders next. I'll try and talk up a bit. So as you can see, we've got a trace, however it's a lot less bright than it was before, and so I'll go and show you what I did to achieve that. What I've done is change this resistor here, and if I show you on the schematic it will make more sense hopefully. So here is our old friend V800 6AU5. That is oscillating and obviously driving this transformer, and then we get higher voltage on the other side. This is our EHT transformer. If you look at this resistor here, this one, that's the one that I took out and changed. At one end it's connected to 350 volts plus 350 volts, and the other end it's connected to our 12AU7 ECC82 anode. If we have a bigger value here, more voltage is going to be dropped across this resistor. If more voltage is going to be dropped, therefore we're going to get less volts here, and if we've got less volts here, we have less volts on our screen of our 6AU5, and if that's the case, therefore the output from our EHT transformer is going to be lower. And while that's dimmed the trace, we're still not out of the woods yet. We've still got no intensity control, but I don't know, we're heading in the right direction. So I'm going to keep digging, still fiddling with the Tech 547, and as you can see I got the cathode ray tube out. So the reason I pulled it was because, if I finally get to my point, these are our vertical and horizontal plates, vertical, horizontal. And earlier on when I was taking voltages on the actual scope, I thought, I don't know, that was what I was doing. I was trying to see if the adjustable voltage on the intensity control was actually getting to the, where do you call it, to the cathode ray tube. So I've got a lot of things in my head at the moment, how to line them all up. And so the purpose of that, I've already pulled these off and also made sure that they were connected. And I took one off, put it back on, and then I noticed that the trace had moved. So that got me thinking, are these pins clean? And I don't know what they're made of, but I've sort of cleaned them up with a bit of fine wet and dry and a fibre pencil, and they're a little bit better than what they were. But if I show you the actual sort of tags that go on there, not very light's not very good, but as you can see, hopefully see, they're very mucky. And I was thinking, well, if they're not making good contact, then you know we're not going to get a proper display. So what I'm going to do is try to find a drill of roughly the same sort of diameter, just give those a little bit of a clean up, because short of putting new ones on, there's nothing much else I can do. Put the cathode ray tube back in and just keep going. Oh dear, with the horrible smell of sort of burning, arcing. So I was probing around in there, arced one of the horizontal, the wires that goes to the horizontal plates, arced that over to the shield there. Lots of sparks, yeah, turned it off. And now this trace is over here. Let's go and have a look, see what damage I've done. Can you see down there? There's a big something is burnt out, a resistor's burnt out. Looks like a lead is completely melted. Oh dearie me. And that is going to the middle tube, V589. Middle tube, I said tube then, I'm that shocked, I'm starting to talk American, shit. Right, well I'm going to knock it off here I think. Repair what damage I've done. And I don't know, I'm going nowhere fast with this scope here. Just going round in circles. I need another fundamental rethink, I think. Can I see any more damage that I've done? That seems to be confined to that area, hopefully. So with that buggered and me needing a sit down and a cup of coffee, I'll wrap this video up here. Again, as with the valve tester, we've got nowhere. We're not doing very well. Well, I'm not doing very well, am I? So yeah, it's at this point you start to doubt your own sanity and your skills in fault finding and all the rest of it. I mean, I know I'm not that knowledgeable, but I can usually sort of push through and get there. But yeah, anyway, thank you all for watching. Take care of yourselves. Ta-ra for now.